In a previous video, I've discussed how active heat recovery works. In summary, it's a new way to heat and cool ventilation air by using a refrigeration system. Stale return air is brought from the building over the evaporator, where it's cooled before being exhausted. The compressor upgrades this heat and rejects it to the condenser. Fresh outdoor air is brought over this condenser where it's heated to its desired set point. No fossil fuels or any other top-up heat energy is required with this system. Geothermal systems have become a popular source of heating and cooling because they also don't rely on fossil fuels. In cooling mode, the system works by removing heat from the building and storing it in the geothermal field. Electric heat pumps are typically used, which move this heat from the building to the ground by circulating glycol through these geothermal wells. In heating mode, the system recovers this stored energy. As discussed in previous videos, upwards of 70% of a building's energy is used for heating, especially in cold climates. Ventilation is often a significant portion of this energy. Because this is a heating-dominated climate, there is more heat required for this building than is added during the summer. Therefore, the ground becomes colder and colder over subsequent years. This results in poor energy performance. FreshAIR active heat recovery can be used to resolve this issue. Unlike other passive types of heat recovery, FreshAIR requires no top-up heat energy from the geothermal field. When using active heat recovery, the ventilation load can be completely removed. This helps to prolong the life of the geothermal system. In some cases, since the ventilation heat load has been removed, the geothermal field can be reduced in size, which can yield substantial capital cost savings. Using active heat recovery to handle the ventilation load instead of relying on the geothermal field can also result in significant energy savings. Even in cold climates, active heat recovery has a seasonal COP of 7 when compared to a COP of 3.6 for ground-sourced geothermal systems. Therefore, FreshAIR active heat recovery has the lowest annual operating cost when compared to any other fuel source. Since active heat recovery has the highest COP in comparison, its annual carbon emissions are also the lowest of any other kind of system. In summary, active heat recovery is the go-to technology for any dedicated outdoor air system, especially when geothermal is being considered. Active heat recovery allows designers to downsize the geothermal field, resulting in capital cost savings. Since it's a completely self-contained DOAS unit, hydronic piping to the ventilation system can often be eliminated. And because heat generated by active heat recovery has a higher COP, building owners can count on lower operating costs and reduced greenhouse gas emissions.